Welcome, students. In this video, we will be exploring the relationships among energy transferred, the type of matter, the mass, and the change in the average kinetic energy of the particles as measured by the temperature of a sample. Before we dive into examples, let's define some important terms. Thermal energy is the energy associated with the random motion of particles in matter. Heat capacity is a measure of the energy required to raise the temperature of a given quantity of material by a certain amount. These concepts have real-world applications in various fields, such as in cooking, where the amount of thermal energy and heat capacity of the ingredients affects the cooking time and temperature. Let's say you have two samples of water, one with a mass of 100 grams and another with a mass of 200 grams. If you want to raise the temperature of both samples by 10 degrees Celsius, which sample would require more energy? That's right, the sample with a higher mass of 200 grams would require more energy to raise its temperature by the same amount as the 100-gram sample. Now, let's consider two different materials with the same mass. One is copper, and the other is aluminum. Which material requires more energy to raise its temperature by a certain amount? Aluminum has a higher heat capacity than copper, meaning that it requires more energy to raise its temperature by the same amount as copper. Finally, let's make a connection to everyday life. Have you ever noticed that it takes longer to heat up a pot of water than it does to heat up a metal spoon? This is because the pot has a higher mass and heat capacity than the spoon. The pot requires more energy to raise its temperature, whereas the spoon heats up more quickly because it has a lower mass and heat capacity. So there you have it. We have explored the relationships among energy transferred, the type of matter, the mass, and the change in the average kinetic energy of the particles as measured by the temperature of a sample. Remember, the amount of energy transferred is directly proportional to the mass of the sample and the heat capacity of the material. The change in the average kinetic energy of the particles is related to the temperature of the sample and is governed by the specific heat capacity of the material. These concepts have real-world applications and are essential to understanding many processes that occur around us.